Just to make sure you're in the right place, we're going to be talking Apache Iceberg, and we're going to walk through what Warner Music Group has been doing with it. I will kick us off. My name's William Rashawn. I'm the industry principal for the media and entertainment category at Snowflake. I have Michael Jones with me, who's going to share a case study and deep dive on how they're using Iceberg and the impacts it's having at the business. Before we do that, I will give a little background on Iceberg. I'm assuming a lot of people, because you've came here, have some familiarity with it, but we'll do a quick backgrounder on what Iceberg is, where it came from, and then some best practices that we see in the media industry and how customers are leveraging it. And we'll share, some statistics on kind of the pace of innovation that we've seen on it as well. So with that, just to level set on what is Iceberg, where does it fit into the picture in a technology landscape? So it's a data lake table format. It's a layer of abstraction for various query engines that clients might be using. The things that we hear from customers and what we see is that it really enables them to open up their data wherever it sits to be able to have a consistent way to access all of that. So you get a lot of the benefits that you might see from using a data platform like Snowflake when it comes to governance, performance, ease of management, and you have that unified layer across all the data sources. When it comes to a format like Iceberg, what we see is that what you're looking for is consistency. You're looking for the ability to have all the teams access the same data and have the ability to go back in time and review the data and how it's changed as well. So the big features that we see, what are the things that clients are getting out of Iceberg and why are they using it? So it's the partition evolution, it's the hidden partitioning, ACID compliance, time travel, and then flexibility are kind of the core features that a lot of our clients get value out of when it comes to Apache Iceberg. We've heard a lot of feedback from customers too that they really want to have as much control as possible. They don't want to be only using a single platform. I think in companies like Warner Music and other big media companies, it's just not realistic to only have one system to store all of your data, given acquisitions and mergers and changes that are happening all the time in the industry. So this gives them an open design framework so they could work with that data wherever it sits. We kind of view it as composability is a word that we use a lot, where you're kind of bringing in best of breed from whatever tools make sense for the data that you might be leveraging. The ecosystem is a big part of Iceberg as well. So, as leveraging that format and that type, you're going to get access to a broader network and system of tools and data sources that become accessible through the platform. And then finally, efficiency. So when it comes to Iceberg, one of the big benefits is you don't have to have multiple copies of your data. You can make sure everyone's accessing data consistently and from the same place. What we've seen very recently, I was just looking at some of the metrics on the media and entertainment side, just within Snowflake, we're seeing a ton of momentum. So just looking over the last quarter, we saw a 300% increase in the number of queries that are being done using Iceberg and the data that's sitting within it, and a 400% increase in the create process within those tables as well. So massive adoption, massive usage, and continued growth is what we're seeing as well. And this is, a lot of reasons why I think we're seeing the gravitation towards Iceberg as the table format of choice. The project has a lot of supporters, definitely not just Snowflake, so AWS is definitely behind it as well. And that rapid growth continues, and you get access to all of the support behind that. Just looking at the momentum from GitHub around the project, This is just a kind of timeline on the active contributors over the past couple years, you could see Iceberg has grown and continues to take off. It's moving faster than other formats like Delta Lake, and some of the big contributors to the project are Netflix, Apple, and Amazon. They tend to be always at the top in terms of contributions for the project, so you're in very good company. How does this fit into the overall systems that customers are using? So the Lakehouse architecture is one that we see fairly widely adopted across our customer base at this point. And there's really these three layers that are within that architecture. So there's a compute layer, there's the catalog layer, and the storage layer. The ability to have separation between these and to understand how they operate is what we'll talk through very quickly here as well. The storage layer is really the foundation. So this is sort of the place where all of the data can come together. You get that benefit of having the compatibility across these different systems when you're taking an Iceberg approach with this. And it's really going to kind of set you up for the ability to collaborate across your teams, across the different entities that might be within your organization. The catalog layer becomes that source of truth. So this is where the teams are able to have those consistent views of the data sets across teams. This becomes a place where that common language comes into place. It has the transactional rigor around it that I think a lot of enterprise customers are looking for as well. And then finally, the compute layer. And this is really where all the work gets done. So this is where you're going to be interacting and querying and processing the data at the top layer. And this is, by having this foundation, this is really what's going to set you up to be able to execute a lot of the innovative things that are happening around AI and analytics that we're seeing in the space right now. These are general recommendations that we see around approaching a Lakehouse analytics approach. The first one would be access, and this is where, as an enterprise, asking yourself, can you securely unify all the data that your team needs wherever it might sit? The second would be performance and understanding the requirements around concurrency and speed when it comes to all the data customers that you're working with. And then finally, empowerment. So are you giving the teams that you're working with production-ready data to be able to build the products that they want to build? And that's an area where we've definitely seen the pace of change really pick up over the last couple of years, the ability to deliver code faster, deliver data faster, and the demands that all of our clients continue to increase there. So that's definitely an important one. And then finally, this is sort of where things end up from a very high-level architecture perspective. And what we want to be able to do is, support the enterprise customers that we work with, make sure that the entire business is connected. You have that ecosystem of data sets that you're working with. You have the ability to partner with all of your customers and external partners, but also internal teams. To eliminate some of the complexities that used to be there around having copies of data and ETL processes. It really becomes simplified when you take an Iceberg approach to your data lakehouse. And then finally, just thinking about, what are the benefits when you get there? So what happens as an end state? You're going to have better query performance. You're going to have cost optimizations. You'll have better data integration, scalability, and then finally, you can do all of this in a cross-cloud environment. And with that, I will turn it over, and Michael's going to take you through exactly how this comes to life for Warner Music.
Yeah, thank you. Hey, it is, I guess I should click ahead. There we go. When the Iceberg Saves You is what I entitled this. Maybe a little dramatic, but not so much at a complex organization like Warner. So just a little bit about me. My name is Mike Jones. You can call me Mike or Michael. I am the director for data engineering. So I own basically all of our ETL and pipelines at Warner Music Group. And it's a very complicated environment with a lot of history. And you're probably here because you probably have a complicated environment too and need Iceberg in your life. So what I would say about that is that this is just sort of an opportunity for us to share a little bit about our experience working under a lot of constraints, some things we can control, some things we can't control, and being able to actually really create a seamless data environment with a very complex system. So I'll jump into that. This is the agenda. We'll be going over, I'll tell you a little bit about WMG. Maybe you already know about Warner Music. I'll go over the challenges and just how we built an architecture of interoperability. And that's not just marketing. We actually have this working, which is really cool, with Iceberg as the connective tissue is what we called it. And I'll share some learnings and outcomes with you after that. So Warner Music Group. Warner represents 75 years of music history. So it's a pretty cool place. It's pretty cool history. I mean, you probably see artists up there that you recognize. It's a really, really exciting place to be. And it's kind of funny because it's the first place where my kids were like, Dad, you have a cool job. I'm like, what? I worked in like AWS and drones and stuff. No, this is cool. I guess when you're 10, this music is cool, right? And it is. It's really cool and fascinating and complicated business. And so we actually, it houses numerous labels and sub-labels. And what that means is that we have a very complex, distributed, decentralized environment that doesn't have standardization in a lot of areas. And that creates a lot of challenges for data, and also means that we're in a multi-engine, multi-platform environment. And so what I wanted to say, too, at the outset here is that, being an AWS alumni, if you looked at my LinkedIn several years ago, I'll appeal to my favorite leadership principle, which was learn and be curious. If you're going to do anything with this stuff in an interoperable environment, you need a lot of curiosity. And curiosity is kind of the lifeblood of an organization that can actually achieve great things. And I think we've done some really, really cool stuff with Snowflake and Iceberg and AWS and other platform engines like Databricks over the last couple of years. And so I'll get into a bunch of that. So I talked a little bit about this before, but it's important to note that WMG Tech is a centralized corporate function that sits underneath all of these decentralized labels. And that is really challenging because those labels can make a lot of autonomous decisions and have for years that have created a lot of history that we can't just snap our fingers and change. And so what that means is even if we want to introduce new technologies and practices and tools, new engines, or teams want to use different engines, all this stuff is still there and it's evolving too. And so this is the kind of context in which we have to kind of challenge. This is the challenge that we have with this stuff. So in particular, we have all of our, because we're a multi-engine, multi-vendor environment. And so all of our classic Lakehouse and our BI, our analysts, like our recorded music analysts, marketing, all of them are on Snowflake. So we have hundreds of pipelines, I think 600 pipelines in Snowflake that are running from raw ingest all the way up through to gold layer. And our analysts and RM analysts, our BI, they prefer Snowflake as their tool of choice. And on the other hand, we have a sizable portion of infrastructure on Databricks where our new data mesh is built. So you can imagine we have Databricks over here with a data mesh, and then we've got our classic Lakehouse medallion architecture over here with BI and RM, and they need things from each other. And so that's where we started to really explore and get on this journey of learning to figure out hey, how can we make all this work together? And so that's the real question. How do we take huge volumes of data and be able to access it across multiple engines for a huge distributed, diverse, decentralized group that they don't really want standards all the time. And so you can't just make them do it a certain way either. So this is how the environment that we're in, and it poses a lot of challenge. And if we do it right, then we support our artists, our songwriters better. We can help them make better decisions with the data, and music thrives, is basically how it works. So it's really exciting, a lot of crazy, challenging problems for us to deal with, but that's why we're here, and that's what's fun about it. So I wanted to jump into just a few of the use cases that we have, just to give you a flavor of it. So one of them is we just launched WMG Pulse. And what that is it's an artist and songwriter-facing app that serves up analytical insights and financial transparency. So it's a pretty cool app. That thing actually sits on top of data products in the data mesh that themselves are using data from Snowflake that's raw ingested and transformed under Snowflake. So that's one challenge. So how do you do that? Like, do we manually copy data around? Do you use federated queries everywhere? Do we reverse ETL it? These are like the challenges that we hit. Second example, I mentioned our BI, our marketing, our recorded music, and analysts. They're using like Snowflake. The entire BI and analyst community is heavily built onto Snowflake. They use Tableau. They use a lot of direct queries. They have a lot of what we call homebrew ETL that they built on top of the fundamental data pipelines. That stuff is all on Snowflake, and it has millions, actually, sorry, so it's like billions of queries a month. And it also now needs data from the data mesh too, as well as other sources. I'm talking about that, but we've got stuff in legacy Postgres, Oracle, all over the place. Then we have our ML team. They prefer to use ML Flow, so that's sitting in Databricks, but they're working on a lot of data in Snowflake. And we actually do AI and ML on Snowflake as well. So there's this back and forth of data across both there again. And then there's third-party integrations where we literally need to share hundreds of terabytes of constantly evolving data with third parties and receive data from those third parties. So like a good example would be like Spotify sends us streaming data. So we get billions of rows a day from these streaming things because you all like to listen to music. And so we get lots of streams coming in all the time. And so that stuff comes in through Snowflake and then has to go out to all these other systems. So we have a lot of challenges. And I wanted to start with like the goal of what we're trying to do, okay? So I'll put this image up in front of you right now because I'll come back to it. But I wanted to show you this kind of vision of it. So you'll notice in the middle there, if it's not too small for you, that we have this unified Iceberg data layer, okay? And then on the right, you've got the engine. So you'll see you've got Snowflake there, Databricks, there's all these legacy analytical tools, there's a bunch of third-party stuff flying around in there. On the other side, there's sources. This could be like Spotify, DSPs, that type of thing, like we get. And so this is a goal. This is a goal is that we somehow live in this beautiful harmony where we get tons of data from all these eclectic sources. It's just magically all in the right place, and then all of these things with all their differences can just use that data magically, right? And it's not quite magical, and it didn't get there magically, but it's not that far off now, which is kind of cool. So what I wanted to jump in is use and show you is just use one example as kind of a case study for this. This isn't the only example we've got, and we're doing a lot of other stuff, but this one was fairly easy. It doesn't have much proprietary concerns, so it's really easy for me to talk about. So I wanted to share about WMG Opus on Iceberg. Now, Opus is an internal tool that's used by, I think it's about 700 users at Warner Music. So it's our most used tool. And it essentially is a tool for viewing like streams, social data, charts, playlists. You can go there and look at how an artist is doing on all of these metrics internally. And it's also externally facing. We actually have external users who connect to this thing. And so this tool is, it exists as sort of it's a React app, well, React website that sits on top of a legacy Java Spring backend called DV API. And that legacy Java Spring backend actually does a lot of direct reads of Snowflake. So just for the streaming data alone, and by that I mean like you're listening to music, there's 15 APIs with all of their subroutes that themselves call dozens of different tables in Snowflake directly. So you're like, why are you querying Snowflake directly? That's a really good question. Operational thing, querying analytical space, not maybe the best way to do it, but that's what's there. And it's built that way, and it can take 20 seconds to query at times, which is not the best, but it's there. And these are the kind of constraints that we operate under because this is the most used tool that we have. And so one of the challenges that we hit right away was that Opus actually needed to use a new streaming product in our Databricks data mesh. So now you can imagine this stack here in Opus, and I wonder if I have it on the next slide. Yes, I do. Here we go. So this one here, if you look at this, we've got Opus sitting there on top of what's called our DV data visualization API. So this is a legacy API, the Java Spring thing I was talking about. And it's reading from Snowflake Gold, Snowflake Silver, Bronze, which is all processed through there. There's a lot of pipelines that are going in. This is hundreds of terabytes of data that's processed through here and aggregated and transformed and retransformed and re-aggregated and eventually served up to be like, hey, you know what? Your track is outperforming in country X. So this here is just the high-level architecture, and we needed to actually get data from Databricks into DV API. And so it's like, well, what are kind of the options we have here? Well, we could migrate DV API to Databricks, but that would be just prohibitive. For one thing, there's tons of other APIs that run on it. There's a lot of other Snowflake stuff that's going to live there forever. We don't want to change that stuff. We don't actually have that big an engineering team on Opus and DV API anymore. It's actually largely pretty small. It's in like KTLO mode. But it's still heavily used by the business. So again, you got to work within the constraints that you've got. The other problem is that it's extremely disruptive to go and change this API out from under the hood, like to re-engineer it. It's a huge effort. And again, as I said, the BI and analysts prefer Snowflake. So what that means is they're actually reading the tables directly themselves and looking at them and getting information from them, and that's where they want to do it. So we can't just go like, pull the rug out and just be like, okay, let's put this over on a different engine. That won't work. And like I said, there's stuff that are not on that engine. We actually need it from both. The second option is what I kind of threw up here is like legacy Delta integration. This was, I like to joke half my production stack is on private previews, but we were actually looking at like DLT private previews with Snowflake on like being able to just direct read Delta. It didn't work very well, and it's since evolved into a much better system, but this was back in 2023. It's not really a great option. But we're looking at this. And then the third one was Uniform Iceberg. Now, if you know Uniform, that's like Databricks Unity Catalog Iceberg can export. So into Iceberg, they can just take Delta, a Delta table, which is Parquet, and you just wrap a Delta log metadata around it, and then ploop. And lo and behold, if you go drop that thing into S3, Snowflake Catalog can go and point at it and read it through the REST API. So that's pretty cool. So this was like, we're like, maybe that'll work. So that's what we did. We set this up. We set it up so that we would actually take the streaming data from this data product and using the same Snowflake tables that the API is reading from, we would actually just point those tables at essentially using the REST API to S3, we just point them at the Iceberg tables and produce them there. Which meant, and I think this is what's really cool and probably one of the biggest changes over the years, we could bring Snowflake to the data, which is really, really cool, right? Like we didn't have to bring the data in, we could bring Snowflake to the data, which I think was really an awesome thing that we were able to start doing. And this was just the start of it. So what we saw with this, and this is really the key insight, was to make our entire data layer platform and engine agnostic. This is like the big idea that kind of clicked at a moment. Like, wait a minute, why don't we just actually make it agnostic so that I can point Snowflake at anything I want, and Snowflake can produce whatever I want in Iceberg, and vice versa with other engines like a Databricks. And that way I don't actually have to choose. I can get the best of both worlds simultaneously. And actually, we have a lot more optionality and strengths, and you can leverage the innovations that are coming out of multiple platforms at the same time, which is really interesting. So we had our initial success with Iceberg, and a little interesting. There's supposed to be a diagram there, but I'm not sure where it went. Maybe it's the next slide. Oh yeah, there we go. Okay, cool. Not sure why I did that. Okay, so we had our initial success with Iceberg, and this is where sort of our first application of Snowflake. It was running 1 billion queries per month. It's running 1 billion queries a month through those Snowflake tables into Iceberg. And so that was half the battle to start. The second half is how do we get the data products to read data from Snowflake? I haven't talked about this yet, but ironically, the data mesh actually is reading tons of bronze and silver data from Snowflake. So initially, the team started out doing this with federated query. And if you don't know what federated query is, basically what it is from say, Databricks perspective, what they're going to do is you're going to fire up a cluster, it's going to dispatch a query over to Snowflake. That cluster is going to sit there waiting, spending money, but it will sit there, and Snowflake will actually run the query, and then the answer comes back. So you actually have double compute happening while your query is dispatched over, and then it comes back. So this works, but it's kind of not great in some ways because your EC2 usage just skyrockets while it's handling all of this metadata processing and everything else. So this was what we had set up initially, and eventually what we did was, especially through the innovations coming out of Snowflake, we were actually able to flip this over to federated catalog with Iceberg, which essentially meant EC2 really down. We didn't have to actually spend that for all of the processing. We didn't have to dispatch queries. Databricks could directly read the tables published is not the technical word, but the tables that are available from Snowflake, either through managed or external Iceberg in Snowflake, which is really cool. So that brought us to this. And this is the thing that is kind of like, wow, we actually went and did this. But you remember the diagram I showed you on the left? That was the original architecture. If you look at the bottom there, you'll see we've got that red box there. And what's happening there is that is essentially the data product that lives in Databricks. And what it does is it uses federated catalog to read from the bronze, silver layers in Snowflake. And it actually makes the result available back to Snowflake via Iceberg. Essentially, what I'd said, you can publish Delta tables as, because they're so similar, you can publish them essentially as Iceberg, and Snowflake can just pick them right up, and then they're available. And what was really cool is that this actually worked, and it worked really well. Like, we only saw a performance drop of about 10% in terms of query performance from the application, and that didn't even matter because the hit was absorbed by the parallelization within the app actually, the Opus actually running. So what this meant was we were actually able to interleave different engines together pretty much seamlessly with 0 copies in a performant application, and we did it without any of the business users noticing. So we just did this under the hood. We told them it was happening just in case something went wrong, but they didn't notice. They were like, we didn't notice a difference. We're like, yes. That doesn't always happen for us, believe me, but it happened this time. So I see some guys laughing. But yes, that doesn't always happen, but it did work this time. So this actually worked. And this was like something that would have been like, we couldn't even imagined a few years ago in terms of the level of interoperability that we could achieve. And so this actually ends up like opening up the doors for us. So what we did was we expanded our success by sort of expanding our Iceberg usage. So this is just another example where, like, why use a REST API on S3 when Snowflake has what's called native Iceberg? I don't know if that's what you're still calling it, but essentially, like, Snowflake can actually manage the table. I think it's managed Iceberg, can manage the table for you. And so you don't actually need, it actually appears as like a Snowflake native table, but it's available for external readers if you want to read it. There's some constraints, like they can't write to it naturally, but that's perfect for us. We just want to make data available. But this is really, really cool because now we can use this to share data with third parties and actually other parts of our business, as well as we can get other vendors and partners to give data to us like this, which means we don't have to spend a ton of compute processing ingestion of rows and stuff. We just take an Iceberg table, Snowflake can wrap it up one way or the other, whether managed or external, and we can make it available, and then we can seamlessly weave our engines together, which opens up a lot of doors for machine learning and AI where they have to go and grab sources from all kinds of wild places in our business. So this is what's really kind of an exciting thing for us. And this lands us on this, what I call unified interop between data platforms. So so I've got a kind of like space, you can kind of see the different options there, like how do you read from Snowflake? Well, a Snowflake managed table is really great for that. So that's what we're doing. We're creating these Snowflake managed tables. And there's so much work happening on this front on Snowflake. This is getting better like by the month almost, which is awesome. Getting more seamless, more efficient, almost monthly. And so it's really, really cool what's happening, but we're actually able to then make this data, any of our data, which is about 3.2 petabytes in Snowflake, and we've got about 4 petabytes in Databricks. And so between it's about 50-50. Between that amount of data that's in these two spaces, we're able to make any of that data available for any side of it. So that means we don't have to actually rewrite engines. We can just bring the engine to the data, which is really, really slick for us. For reading into Snowflake, same thing. We could use an externally managed table, which is what I described earlier with Opus, and this data just flows right in, and we're able to do it. So there's a number of edges to this, of course, because with anything like this, there's a bit of devil in the details, which is why I mentioned curiosity at the beginning. It doesn't always click together perfectly. There's a lot of little platform differences, such as how they treat metadata or how they update it between things that can be challenging. And I have a bit on that later. But this is where if you can kind of get over a bit of those, what I call just teething pains, because it's way better than it was before, you can actually get over those teething pains, and then it just works pretty seamlessly. And those things are being improved constantly, which is awesome. So I just outlined there when you want to use either Snowflake managed or externally managed. You can go and dig up on that. There's plenty of documentation on it. But by putting those two approaches together from a Snowflake perspective, you're actually able to get the full in and out interoperable story in a format that is widely supported. And I mean, you saw it on the graph, but really not a lot of engines are reading Delta Lake natively, for example, in our environment. So we just don't have that option, even though a lot of our data is in DLT, right? So Iceberg is the way for us to go. And so what happens is that Iceberg becomes this interoperability layer, and it turns our data mesh, Databricks, and our classic data lake in Snowflake into this unified, multi-platform, collaboration-friendly system. And it's not just marketing speak, it actually works. And they had teething pains along the way, but it works, and it works really well. And it works so well for us, we're actually, even the engineers are visibly excited about it at this point. They're just wow, wait a minute, we could use Iceberg over here and it will simplify this, and we can use it over here and it'll simplify this. And now we're basically just constrained on our own ability to convert these tables and make them available and stuff. But once they are there, it becomes sort of the unified way where if someone says, I need this data, we're Icebergify it. I don't know if that's a verb yet, but Icebergify it, and it's there for you, which is what we're doing. So just this month, hundreds of more terabytes are being Icebergified right now as I speak, and it should be done. The job should be done today. But we're doing it literally more and more with more data to make it available and make it more seamless, which is really, really neat. So that means that Snowflake, for Snowflake and any other engines, Iceberg becomes this API between the systems. That's the other way that I like to think about it. You've got this data layer that's agnostic of the platform that you're on or the engine you're on, and you can store that data layer wherever you want. And actually, the engines typically, because they're natively supporting it, even if they own it, like a Snowflake managed table, it's effectively an engine agnostic representation. So it's really nice. You don't actually have to move the data out. You can just you flip switches and suddenly it's available, which is really, really cool. So what this means is now, with Iceberg, we are actually processing billions of queries a month. We have hundreds of terabytes with Iceberg right now. We have started on this journey of integrating vendors with it, external third-party vendors. We have to send a lot of data out to third parties, and we have to get a lot of data from third parties. And we have kind of old legacy reverse ETL systems. They work for doing that, like CDC, that type of thing. But this is way better. We want Iceberg to be actually the API that if you were to go to Warner Music Group and want an integration, we'd say, oh yeah, Iceberg. Because it's actually kind of difficult for them if they don't have Snowflake, it's harder for them to connect to our Snowflake and that type of thing. So this makes it way, way easier. So what this means is that we actually are able to move the data back and forth between platforms and make it available in this triangle of third parties to multiple engines, and in the middle we've got this agnostic data layer that you can read and write from any position and use for any use case without costs, without extra copies, without having to do translations, and all the benefits you said before. It's ACID compliant. You get actually history. If you look at the architecture of how Iceberg is, it's really cool because you're essentially just updating pointers to manifest files. So as long as you haven't vacuumed up your old data, you actually have time travel going backward for Iceberg. So it's really neat. And Iceberg v3 and v4, I think, are coming out. So it's there's a lot more that's coming up too. So I'll talk about a little bit about the learnings, and we're going to open it up for some discussion, I think. So here's a few things. So this is some of the Snowflake ones, Snowflake learnings. And then I've got a little bit on outcomes. So initially, and I think actually almost all of these things are in progress right now, actually. So that shows you the rate of change. But initially there was like no fail-safe. Like you had to manage your own backups and versioning. I think the Lakehouse team is actually doing some pretty cool stuff here now as well. Right now, presently, there is a conversion compute required if you migrate from standard Snowflake tables to Iceberg. It's like a one-time unload and reload of your data. It can be pretty big if you're doing it for like a large amount of data, but if you have a large amount of data, it's relatively small compared to what you're probably spending in compute anyway, and then the benefit is quite worth it once it's done. So this is a little different because on other engines like a Databricks, because it's DLT and it's in Parquet already, they just wrap metadata around it, whereas Snowflake still has to do this conversion thing right now. But that's in progress right now with them, which is really cool. I think there's gonna be some really neat changes there. Partition file sizes. So one of the interesting things was that for a Snowflake external table, the initial partition size was 16 megabytes, which if you know anything about Iceberg, they recommend like 256 to 512. And what that means is that, let's say you have 1 billion queries a month, and your partition sizes are 16 megabytes, and you need to prune data for these queries. If you might do the AWS engineer math in your head, you might be thinking, oh, wait a minute, that probably means that you're going to get a lot of API calls. And you're right, you get a lot of API calls with something like that happening. So this initially hit us, and like our API usage just went skyrocketed. So that was really interesting learning. It's like, okay, and then we worked with Snowflake, and we got 128 megabyte partitions, and came right down. So that was a really interesting learning there. We were able to tune this partition size and make it much more efficient there. And of course, that would apply to an external table. A Snowflake managed table would handle it for you natively, which is really cool. The external one, you're responsible for storing it, and Snowflake basically has a metadata pointer that uses it. So that's why you have this like sort of custom configuration that you have to do on it. And then there's some other issues, like we've hit like auto refresh can sometimes stop silently, and so this is what I mean. There's these little edges that you gotta monitor and just make sure it works in the integration that you have. And so what we often have done with the deployment is we actually just run an Iceberg in parallel with an existing system, or we monitor it for a week or two and we just make sure that it's working, and then we flip it over. And on the other side, so these are some of the Iceberg learnings from the other side. Uniform has its own constraints. The client access is read-only. So if you want to write to anything, you have to go through Delta. That's similar to like a Snowflake managed table, but it's a constraint there as well. More importantly, though, Uniform didn't work with deletion vectors, and it didn't support multi-table, multi-statement transactions. And if you've done anything with a really complicated multi-statement transaction in Snowflake, you really feel that when it's not there. And it meant that for some of our streaming jobs, their aggregates would not come together in a synchronized way. So we'd actually have like, oh, the month-over-month streams don't quite match the week-over-week streams for like a couple of hours. And that's kind of a pain. So they're also, to my knowledge, working on these things as well. So the next version of Iceberg will solve that, which just makes it easier to bring Snowflake to that data and vice versa, which is really neat. So I won't go into too much about like choosing the format, but there are options for how you can do it with like, you can do Delta with Unity Catalog, you can choose native Iceberg, or you can choose, you can use Uniform to bring like native Iceberg and Delta tables together. But just the takeaway here is that apply curiosity, because there's gonna be edges involved with these things. And there's sophisticated integration between the metadata management between engines. And that metadata management, it doesn't just always plug in. Sometimes it doesn't work. So we've had to do like custom jobs that have run for a temporary period of time that just update metadata for this. And actually we've worked directly with partners like Snowflake, and they've actually like enhanced the offering, and then that we didn't have to do that anymore, which is really cool. So outcomes. Where did we land with all this? I think you probably got the gist already, but it's working pretty well for us. So improved efficiency. So one of the big things is that massively reduced copies, compute, and EC2 for all of these shenanigans that we're doing moving data around. So it's actually really come down. We had a 70% reduction in our EC2 usage from the Databricks side in terms of managing metadata and everything, which is really great. So it helped reduce our cost there. We also got this dream together of a single, consistent data layer and source of truth where we have applied it. So that means our internal tools like Opus and externally facing ones like, or artist-facing ones like WMG Pulse, our ML feature store, they're actually able to use the same tables in an engine-agnostic way across these different offerings. And that's a really big deal for us because we actually have a business where a lot of business users are skeptical of the data, right? And you probably, if you're in a complex organization, they're probably like, can I trust it? And so one of the worst things for trust in data is if you have two clocks, right? Like, so it's not good when you have different representations. So I view Iceberg as a lever for helping with that organizational problem, not just the technical one of trust in data, because you can at least get down to one clock and not have a two-clock problem. And once you're there, you can start to characterize that data and prove it's good or correct it or show how good it is. And you don't have to do that multiple times because anytime someone sees a different data source, they're gonna go and ask, wait a minute, which one's right? Is this one right? And they probably will have a bias about it too and be like, I think this one's right. So like a lot of the requests I get from our business users are like, hey, I saw this data anomaly and it doesn't make sense. And so can you help us figure it out? We have a thing that we need to launch yesterday or something like that, right? So it's really quite an interesting space to be in where providing this one single representation of the data also helps us to build trust with stakeholders in terms of what that data is. And it simplifies our effort to characterize and improve data quality as well. The other thing is we saw shorter time to get insights out, so we didn't have to set up complex, sophisticated systems for serving up data to WMG Pulse. And what that meant was we were able to actually leverage, we brought Snowflake with all of its data to the data products that are powering Pulse. So Snowflake is underneath a ton of that data as well, and we didn't have to build a ton of complex infrastructure to do it. We were able to just Icebergify it, and it worked. And so what that means is that we're actually able to serve these things more efficiently. We can deliver insights faster. And by delivering insights faster, I mean we can spend less time figuring out this infrastructure and more time actually trying to build insights. Like, how's an artist doing? How can we help them perform better? What recommendations can we make? How do they think about the changing world of technology around them? And we don't have to do this like, oh, I got to build a whole bunch of infrastructure to make something just available for me to start asking the question. The important questions, right? So, I think I'll come back to this because this was like the big outcome that we had. I think what we've managed to achieve, and it's not 100% there yet in terms of applying to all of our data yet, but for where we're using this, we actually have what I think is genuinely a future-ready open ecosystem that has this platform engine agnostic data layer that can be accessed from either engines we want, even other external ones. And that actually allows us to basically make our huge history of structured data available for the next generation of things we're doing, like our machine learning and AI. Because one of the things that structured AI work has to do is it has to access all of the data that you have across your organization. So if you want to do that, you really want to have your data in a platform agnostic way because our future is going to be multiple different, probably like half a dozen different engines potentially running different AI workloads on things. And a lot of the businesses spinning up work on AI themselves as well, and everyone's exploring this. And so making this data available and saying like, this is where you get it, is really, really cool, really important. And so that supports team autonomy while helping us to bring a standard that can actually work for people, right? Because it's hard to push a standard that's not beneficial, but if everything is really accessible, pretty obvious benefit. Okay, I think that's it. That's all I had today.
All right.
Yeah.
I think that's a wrap. Thanks, everyone. Thanks for coming out.